So, ALKANONE, or also called ketones, they are also a family of carbonyls. That is, they have that CO group. So, we'll start with some important characteristics of ALKANONE that you need to know at the basic level. It might not be everything, but these are just what you need to know. The first thing is that ALKANONE are represented by the functional group RC_O R prime. Now, this R prime means that these two R group does not necessarily have to be the same thing. They can be different. Now, unlike alkanals, the R group here must be an alkyl group. It can never be hydrogen. That is a very, very good distinction between this and alkanal. Now, the second one you need to know is that the general molecular formula for ALKANONE is 2CnH2n plus 1CO. That's two alkyl group attached to a carbonate group. Now, the next thing you need to know is that the carbonate carbon in an ALKANONE is sp2 hybridized. It's sp2 hybridized. That it has an hybrid orbital of sp2. Now, another thing you need to know is this, that ALKANONEs also undergo nucleophilic addition. Or you can say nucleophilic attack, due to the presence of the electrophilic carbonyl carbon. Now, ALKANONE can do this because the carbonyl carbon is electrophile. Electrophiles are reactive species that can accept a pair of electrons, while nucleophiles are reactive intermediates that can donate a pair of electrons. And this is very important in their reaction mechanism. Majority of the reactions they undergo involve a nucleophile attacking the electrophilic carbonyl carbon. Now, for the most part, the next one that you probably need to know is that ALKANONEs alright, so IUPAC nomenclature of ALKANONE, well, it follows the general rule as all other IUPAC nomenclature we have been doing so far, starting from the alkane, although there are some unique rule that is specific to ALKANONE, which is what I would like us to know. The first thing you need to know about ALKANONE is that the carbonyl carbon in an ALKANONE can be anywhere else except at the terminal. That's at the first carbon or the last carbon. If you have a carbonyl carbon at the ends, that's terminal, it's an aldehyde or an alkanal, not an ALKANONE. So the carbonyl carbon of a ketone or an ALKANONE must be anywhere else except at the terminal. That's the first thing you need to know to identify an ALKANONE. The second thing is that carbonyl carbon must be given its least possible number, either from left to right or right to left, in the longest continuous carbon chain. That is, you must respect the functional group first before you respect anything. General rules remain the same. That substituent group must be named in alphabetical order. If there are more than one, you use prefixes, and you must write substituent group first before the parent name. The rest remains the same, but these two are key when naming ALKANONE. So it's time to draw structure and let's name them. Right. So these are beautiful structures of alkanone from the fission to the condensed to the skeletal form. As usual, we'll start with something simple so we can motivate us, and then we'll go into the taxing one. Now, here, structure A, the first thing in structure A is structure A ketone. Well, let's check together. First thing, check the CO group. Is that a terminal? Look at structure A. This is our CO group. It is neither here nor here. So this is a ketone. So we are good to go. And the next thing is that the carbonyl group must be given its least possible number, either from left to right or right to left. Now, in your book, like labeling it, right, this is your left hand side and this is your right hand side. Now, moving from left to right, let's see the position of this carbonyl carbon. Can write it somewhere here. From left to right, left towards right. Now let's count. We have 1, 2, 3, 4, 5. The carbonyl carbon takes number 5 from left to right. So this is 5. Now, from right to left, let's count. We have 1, 2, 3. Takes number 3. Count again. 1, 2, 3. So from right to left, it takes number 3. So which one is smaller? 3. So we count from right to left following a pack rule. So it's going to be, the chain is going to be 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon in this chain. Now look at structure A. Is there anything in structure A here that is neither carbon, hydrogen, or this oxygen as part of the functional group? Well, as you can see, there is nothing like that. So there is no substitution or attachment group. So just name straight as the parent name. So the parent name is 7 carbon. Remember, IUPAC rule, like I've always been saying, is parent name, position, and functional group. So the parent name is 7 carbon. So the parent name of 7 carbon is hept, as in heptan, as in alkan. So it's going to be heptan. Now what is the position of the functional group? 3. So it's going to be 3. And what's the functional group name? Which is the ome. So it's going to be heptan 3 ome as the name of this structure. And that's about A. Now B. B is in condensed form. And why is it called condensed form? It's simply because the bonds between carbon to carbon are not shown. They are hidden. And that's why it's called condensed form. So as usual, like I've always said, if you see a condensed form, draw it out. It makes your work very easy. So let's draw it from the left hand side towards the right hand side. From the left hand side, we have CH2Br, the group. So it's going to be CH2, and then we have Br. Remember, in organic chemistry, there is no order. Just make sure your bonds are correct. So we've done this group. Now this is the next group, which is CH2. This is the next group, CH2. This is the next group, CH2. This is the next group, CO means this is drawn C double bond O. We have CH2. The next group is CH2I. Oh, this is a mistake. Should not be CH2I. Should just be CHI. And then we have CH3 as the last group. So this is the straight chain version of this condensed form. So now follow the pack rule that the carbon that bears the double bond must be given its least possible number, either from left to right or right to left. Now you can label your structure. This is the left hand side and this is the right hand side. Now from left to right, let's see the position that this carbon takes. So we have 1, 2, 3, 4, 5. Count again. 1, 2, 3, 4, 5. From left to right, that carbon that has double bond takes number 5. So left to right takes 5. Now from right to left, you have 1, 2, 3, 4. Can also count again. 1, 2, 3, 4. Right to left, it takes 4. So right to left is 4. So which is smaller? we choose 4 based on hyper rule. So we label from right to left. So it's going to be, the chain is going to be 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 carbon in the longest chain. Now, the next thing you check for groups that are not carbon and hydrogen or oxygen that is found in the functional group. So look at structure A here, structure B here. You have bromine here and we have iodine here that are not carbon, hydrogen, or oxygen. So they are known as substituent group or substitution. So name them first and in alphabetical order. So bromine is on carbon 8, which is B. So B comes first in the alphabet. So it's going to be attached to what carbon 8. So it's going to be 8 bromo. Always remember, use hyphen to separate letters, numbers, and letters. 8 bromo. Now the next attachment is iodine as carbon 2. But we name iodine as iodo. So it's going to be 2 iodo. Now, is there any attachment or substitution again? No. So the parent name is going to be 8 carbon. What's the parent name of 8 carbon? Oct. Remember, hyperpolis, parent name, position, and functional group. It's something that you should be familiar with. It should look like a song, parent name, position, and functional group. So parent name is oct, as in 8 carbon. So it's going to be octane. Octane. What is the position of the functional group? 4. So octane 4, and what's the functional group name? One. O-N-E. It's not 1. One. Alright, so that is the name for structure B. Now for C, feel free to use the same idea for B to do C. Feel free to pause the video and try it. Let me leave it blank for now. Attempt it and see if you get the answer when I do it later in this video. Now for the fourth structure, I jumped from C to 4, no problem. Now it should be D though. For the structure D, we have a skeletal structure. Now why is this called a skeletal structure? It's called a skeletal structure because you're not seeing carbon, hydrogen, you're just seeing line. Now I've said that you see this thing a lot, not in basic level, you see it in university level in Africa here and beyond. So the body rule still remains the same, doesn't change. So the carbon that bears double bond must be given the least possible number, either from left to right or right to left. Now, this is carbon that bears double bond. So let's label our structure. We have this is left hand side and this is the right hand side. Now, moving from left to right, let's see the position that this carbon takes. So it's going to be 1, 2, 3, 4. Every dot is a carbon, so we have 1 dot, 2 dots, 3 dots, and 4 dots here. And that's the carbon. That's number 4. So left to right, that carbon takes number 4. Now, moving from right to left, let's count the position of this carbon. We have 1, 2, 3, 4, 5, 6, 7. You can count again. We have 1, 2, 3, 4, 5, 6, 7. So right to left, we have 7 for that carbon. So which one is smaller? 4. So you choose 4 based on hyperpool. So it's going to be how we know about the chain. So the longest chain is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can also feel free to count in every direction, but remember it must be longest continuous chain. Because if you say you count like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is not up to 10. So our longest continuous chain is 10. So the next thing you check for groups that are either not part of the longest continuous chain or they are not carbon, hydrogen, or oxygen. Now if you look at structure D, right, like I said, this is supposed to be structure D. Look at structure D. This group here that I'm going to mark and this group here, and I'm going to also mark. They are not part of the longest continuous chain. They are only attachment group. That's their branches. Let me use that English. So now, the next thing is, at least this one has been established that this group here is CH3 because this is a dot attached to one line, CH3. Let's say, what is this group? Remember, it is a group. Now, this is a dot, right? Now, this dot is attached to one line. So what is here is supposed to be CH3, based on what I've been saying so far. So that dot here is CH3 because it's attached to one line. This is a bond because a line is a bond. And there's another dot here. Now look at this dot. This dot here is attached to two lines, this line and this line. When a dot is attached to two lines, what you have there is CH2. Now, if you add these two groups together, you have two carbon, that's C2, and 2 plus 2 is 5. That's 5 hydrogen. The group C2H5 is called an ethyl group. So this whole group here you see here is an ethyl group. Now what you have here is a line, a bond that's attached to this carbon, and this carbon is part of the chain, so you can't count that. So what we have here is ethyl group, this is methyl group or methyl group or ethyl group, irrespective of how you pronounce it. So ethyl group substituent, methyl group substituent. So we must name them first in alphabetical order. E comes before M. So what's the position of the ethyl group on carbon 7? So it's going to be 7 ethyl as this group. Now the next attachment group is this methyl group on carbon 5. 5 methyl. Now is there another one again? No, there's no other branches. So remember now parent name, hyperpolis, parent name, position, and functional group. So it's 10 carbon. What is the parent name of 10 carbon? Decan. So it's going to be decan. What is the position of the double bond of the functional group? 4. And then the functional group name is what? O. So the name of this structure is 7 ethyl, 5 ethyl, decan 4 O. Now, only to that fact, let me come to this. Let's see if you got the answer. A condensed form, as usual, like I always say, draw it out. So first group CH3, CH3. Second group CH2. Third group CHCl. So we have CHCl. The first group CO, which is written like this, C double bond O. The next group CHBr, CHBr. The next group CH2. The next group CH2. And the next group, which is the last group, CH3. So this is the straight chain, the official form of this condensed. This is the official form of this condensed structure. So the rule remains the same. The carbon must be given the least possible number either from left to right, right to left. So as usual, labeling this is the left hand side, and this is the right hand side. Now from left to right, let's see the position that this carbon will take. We have 1, 2, 3, 4. That's counting left to right. It's going to be 1, 2, 3, 4. So we can write it somewhere left to right. That takes number 4. Now from right to left, let's count the position of this carbon. We have 1, 2, 3, 4, 5. You can also count again. We have 1, 2, 3, 4, 5. So right to left, we have 5. So which is smaller? 4. So we'll number from left to right. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 as the longest chain. So the next thing that we'll do next is to check for groups that are not carbon, hydrogen, or oxygen, or groups that are not part of the longest chain. There is no groups here that are not there is there is no carbon chain, there is no carbon structure that is not part of the longest chain here. So our focus will be on groups that are not carbon, hydrogen, or oxygen. So we can see here we have chlorine and we have bromine attached to carbon 3 and 5 respectively. So we must name them first before the parent name in alphabetical order. So bromine is on carbon 5. We have the name is going to be 5-bromo. Then chlorine is on carbon 3. It's going to be 3-chloro. Is there anything here that is neither carbon or hydrogen apart from the two of them? No. So we have 8 carbon. 8 carbon, the parent name is oct, as in octane. So it's going to be octane. What's the position of the functional group? 4. Octane 4, and parent functional group name is what? 4. So see if you got the answer. That's the name for structure. See, now I'll leave it to you to see if you can get the structure, the name for structure. So this should be E. Now I'll just give you a hint. These two things you see here, they are aromatic structure attached to a carbon. Those two structures individually are called phenyl group. This is a phenyl group. This is another phenyl group. So follow the IUPAC rule for ALKANONE I'll be given so far and see if you can name this in the comment section. Drop the name in the comment section. So that's about it. Thank you for your time. Thank you for watching. I remain mastermind of Mastermind Sciences. Share with this. So let's do that.